Today we're going to cover section 5.4, special parallelograms. Special parallelograms, your objective. After studying this section, you'll be able to apply the definitions and identify the special properties of a rectangle, a rhombus, and a square. Determine when a parallelogram is a rectangle, rhombus, or a square. Here's your class opener. Draw the following shapes and list at least 2 facts about each of them. So try to draw yourself a parallelogram, a rectangle, a square, and a rhombus. A rectangle is a quadrilateral with 4 right angles. So if you see a shape that has 4 sides and all 4 angles happen to be right angles, then it's a rectangle. A rhombus is a quadrilateral with 4 congruent sides. So if you have 4 sides and they're all the same length, you have a rhombus. A square. A square is a quadrilateral with 4 right angles and 4 congruent sides. So if you think about it, since it has 4 right angles, a square is going to be a rectangle. And since it has 4 congruent sides, a square is also going to be a rhombus. Theorem 512. The diagonals of a rectangle are congruent. So if I look in the rectangle, one of the diagonals is going to be congruent to the other diagonal. Theorem 513. The diagonals of a rhombus are perpendicular. So if you're drawing the diagonals for a rhombus, they will end up being perpendicular to each other. Theorem 514. Each diagonal of a rhombus bisects 2 angles of the rhombus. So if I take a look at this rhombus and I look at one of the diagonals, so this diagonal should bisect 2 angles, which means the angle in the lower left corner gets bisected, the angle in the upper right gets bisected. Likewise, if I look at the other diagonal also bisects 2 angles. It bisects the angle in the upper left, and it also bisects the angle in the lower right. Theorem 515. The midpoint of the hypotenuse of a right triangle is equidistant from the 3 vertices. So if I look at what this is telling me, if I know that this point right here happens to be the midpoint of the hypotenuse, then it happens to be equidistant from all 3 vertices, which means if I look at the distance from that point to one vertex and that point to this other vertex, it has to be the same, which I know is the case since it's the midpoint, but it's also going to be the same distance away from the 3rd vertex. So all 3 of those segments are going to be the same length. Theorem 516. If an angle of a parallelogram is a right angle, then the parallelogram is a rectangle. So let's look at what they start with. If they tell us that the shape is a parallelogram, so I know that in a parallelogram the opposite sides would be parallel, and they tell me if one angle is a right angle, then it has to be a rectangle. Well, I know to be a rectangle, all the angles have to be 90 degrees. But if I start with just any one of them being 90, I know that 2 consecutive angles are same side interior angles, which means they have to be supplementary. So I know that if this one's already 90 degrees, the next one has to be 90 degrees. I know that in a parallelogram opposite angles are congruent, so I know that the other angles are also 90, and now you have a quadrilateral with 4 right angles, so it's a rectangle. Theorem 517. If 2 consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. Right. I know to be a rhombus, all 4 sides have to be congruent. So if this is a parallelogram and 2 consecutive sides are congruent, well, I know one of the properties of a parallelogram is that opposite sides are congruent. So the right would be congruent to the left, the top would be congruent to the bottom. All 4 sides are congruent, so it has to be a rhombus. Complete with always, sometimes, or never. A square is blank a rhombus. Well, to be a rhombus, you need to have 4 congruent sides, and a square always has 4 congruent sides. So this is going to be always. The diagonals of a parallelogram blank bisect the angles of the parallelogram. Well, that's only going to be a sometimes because it's only going to happen if it's a rhombus. 3. A quadrilateral with one pair of sides congruent and one pair parallel is blank a parallelogram. And this is going to be sometimes. Because remember, you might have a shape like this where the left and right are congruent, the top and the bottom are parallel, but it's not a parallelogram. Now, if it was the same set that was both parallel and congruent, then it would have to be a parallelogram. Number 4, the diagonals of a rhombus are blank congruent. Well, we know if the rhombus happens to be a square, and a square is also a rectangle, then the diagonals would be congruent. So this is a sometimes. Number 5, a rectangle blank has consecutive sides congruent. And this is going to be sometimes if the rectangle happens to be a square. A rectangle blank has perpendicular diagonals. And this is also going to be sometimes if the rectangle happens to be a square, which is also a rhombus, then the diagonals would be perpendicular to each other. Number 7, the diagonals of a rhombus blank bisect each other. And this is going to be always. Since a rhombus is a parallelogram, and parallelograms, the diagonals always bisect one another. Number 8, the diagonals of a parallelogram are blank perpendicular bisectors of each other. They are bisectors of each other all the time, but they're only perpendicular if it happens to be a rhombus. So this is a sometimes. Quadrilateral ABCD is a rhombus. Find the measure of each angle. And they want us to start off by finding what's angle ACD. So angle ACD happens to be this angle right here. And since I know one property of a rhombus is that the diagonals bisect each other, I know that these two angles right here have to be the same size. So angle ACD should also be 62 degrees. Now I'm going to find out how big is angle DEC. Well, let's see, angle DEC is right here. And I know the diagonals of a rhombus are perpendicular, so angle DEC is going to have to be 90 degrees. Let's look at angle EDC. Well, EDC is right here. And I knew that before, right here was 62. We just figured out that that one was 90. So if I take 180 minus 90 minus 62, I should be left with angle EDC, which would happen to then be 28 degrees. Number 4, angle ABC. Angle ABC is this large angle up here. Well, let's see. I know that since this is a rhombus, it's also a parallelogram. So I know alternate interior angles are congruent to one another. So I know that these two angles are both the same size, that they are 28 degrees. And I know that the diagonals bisect angles, so I know that this is also 28 degrees. So combine 28 degrees and 28 degrees, and you get 56 degrees. Quadrilateral ABCD is a rectangle. Find the measure of each. So looking to find angle DCB. Well, if this is a rectangle, that has to be a 90-degree angle. So its measure will be 90. DAC. Well, I know that this is a 90-degree angle. So if I'm looking for just DAC, I would take 90 minus 29, which is going to leave me with 61. DE. Well, let's see. Looking at how big is segment DE. Well, I know that the diagonals of a parallelogram bisect each other, so DE should be the same length as EB, and we know that EB is 12, so DE should also be 12. Number 4, EC. Well, if I look at EC, I know that the diagonals of a rectangle are congruent to one another, so half of one diagonal should be congruent to half of another, so EC should also be 12. And finally, number 5, AC, the entire diagonal, would be 2 of the halves put together, so 12 and 12 is going to give me 24. And your closure. Describe what you already knew about today's lesson.